So this is our fourth different type of transformation. I'm going to try and make this quick, just so we can get through it. So just bear with me, please. So a dilation. Have we ever heard of this term dilate before? Anyone in here wear glasses? Good amount of people wear glasses. Have you ever been to the optometrist and had your eyes dilated? No? Does no one know what I'm talking about? Some people know what I'm talking about. So when they dilate your pupils, they like shine light into them and your pupils get a lot larger. Right? Maybe that's a bad example. Either way, some of you, if you know what I'm talking about, you know what I'm talking about. So dilating is taking something and making it larger. Have you ever seen like an older person leave the doctor with those big funny plastic sunglasses? Yeah. You know what I'm talking about? You have to wear those because they just got their eyes dilated, which means they opened up their pupils so they could take a look into their eyes. And once your pupils are open like that, they take in a lot more light, which makes your eyes a lot more sensitive. Right? Not that I know anything about science or medicine, but I do know that. So dilating is making a shape larger or making it smaller. All it's doing is changing the size. This is the first transformation we're talking about where we're actually changing the size of a figure. So for this, our pre-image and our image are not going to be congruent for the first time. So we're either going to make it bigger or smaller. We know how big or small we're going to make it by taking a look at the scale factor, which is just the degree to which a figure is enlarged, made bigger, or reduced, made smaller. So we're going to get an instruction that's like basically make your triangle twice as large or make your triangle half as large. And those are the two examples we're going to look at. It's a pretty simple process. All we have to do is figure out the coordinates and then multiply each coordinate. Multiply each coordinate, emphasis on the multiply, by the scale factor that we're given. So in example A, we're going to dilate the figure JKL by a scale factor of 2. Here's JKL right here. It's a rather small triangle. And if we're dilating it by a scale factor of 2, what we're doing is making it twice as big. And my pen is running out of ink. Twice as big. Because of scale factor of 2. If we were going by a scale factor of 3, we're making it 3 times as big. Scale factor of 4, 4 times as big. Right? Makes sense? So we just take, I'm going to highlight my 2 here as well, sorry. So if point J, if you look down here, point J is at 1, 2. We're going to multiply the 1 by 2, and we're going to multiply the 2 by 2. What would my new x coordinate be for J prime then? If we're doing 1 times 2, what would we get? 2. And my y coordinate, if we're doing 2 times 2, what would we get? 4. Let's go ahead and plot J prime on our graph real quick at 2, 4. 2, 4. There's J prime. How do I know what to multiply each coordinate by, Mr. Church? That's a good question. It'll give it to you. Whatever it says the scale factor is, that number is what you're multiplying. That's why we want to highlight the 2 and the times 2's. Then Then we take a look at point K. We're going to do the same exact thing. Point K down here is at 2, negative 1. So I'm going to take my 2, multiply it by the scale factor of 2, take my negative 1 and multiply it by a scale factor of 2, and get my image coordinates. So for my x coordinate, if I'm doing 2 times 2, what would I get? 4. What about negative 1 times 2? What would I get for my y coordinate? What was it? Negative 2. Great job. All we're doing here is multiplying. So then we plot the point, 4, negative 2, go over 4, go down 2. There's my k prime. Give me a thumbs up if you're following what we're doing so far. Okay. Finally, point L is at negative 2, 0. We see that right here on the x-axis where I'm pointing, negative 2, 0. I'm going to take negative 2, multiply it by my scale factor of 2. I'm going to take 0, multiply it by my scale factor of 2. What would my new x coordinate be here? Negative 2 times 2? Negative 4, thank you. What about 0 times 2? 0. Okay, guys, I really need you guys to focus, okay? It's not going to take that long, just for real. Let me plot this last point, negative 4, 0. So go over to negative 4, 0 spaces up and down. It's my last one, L prime. Now we can connect all those dots together. And we see a very interesting image triangle here. It looks like the same triangle. All of my angles are the same. But my size is much different. In fact, it's twice as big of a triangle as we started with, because we dilated it by a scale factor of 2. Like I said, twice as big. Seems easy enough, right? Just multiplying the coordinates. There's no way to do this by counting on the graph. This is the one transformation where you've got to write out the coordinates and do the dirty work to get your new coordinates and then plot it. All right? Let's go the opposite way. We made a triangle larger. Let's make it smaller. If we're going to dilate this other triangle, MNO, by a scale factor of 1/2, scale factor of 1/2 means we're making it half as big. We're shrinking our triangle. If we want to start with point M is at 4, 4. I'm going to take both of those coordinates, 4 and 4, multiply them by 1/2, the scale factor that we're given in the question. M prime is going to be, what's 4 times 1/2? 2, 4 times 1/2, which is 2. So my new point M prime is at 2, 2, right there. And we can see already that our triangle now, instead of being on the outside, is going to be shrunk down on the inside. All right, I'm going to take a moment to make sure you understand what we did there. Now N is at 0, -4. I'm going to take 0, multiply it by my scale factor of 1/2, and -4, multiply that by my scale factor of 1/2, and get my new coordinates. What would half of 0 be? Just 0. What's half of negative 4, though? Negative 2. 0, negative 2. There's my second image point, N prime. Right there on the y-axis, lined up at negative 2. Finally, my point O is at negative 4, comma 4. I'm going to take negative 4, multiply it by my scale factor of 1/2 to get negative 2. Then I take positive 4, multiply it by my scale factor of 1/2 to get 2. And we'll plot negative 2, positive 2. That's my O prime coordinate. And this time, just as we predicted, we see that we've got a much smaller triangle that shrunk down inside of our pre-image. So dilating is just changing the size. We can change it larger by a certain amount. We could change our shape to be smaller by a certain amount. It all depends on what scale factor you're given in the problem. If we look ahead to worksheet 51, you'll see a triangle, dilation of 5, dilation of 2. We're just taking all the coordinates. S is at negative 1, 0. T is at 1, 1. U is at 0, negative 1. And what are we going to multiply each of these numbers by? 5. Right? So S prime would be negative 5, 0. What would T prime be? 5, 5. 1 times 5, comma 1 times 5. And what would my U prime coordinates be? 0, negative 5. Now we just take those 3 points and plot them. Negative 5, 0 is S prime. 5, 5 is T prime. 0, negative 5 is U prime. And now we've got a similar triangle that's 5 times larger than what we started with. The orientation is the same, right? T is still pointing up to that top left, or sorry, that top right corner. So we didn't rotate this at all. We didn't reflect or flip it at all. We just kept it in the same spot and enlarged it. All right? If you have something like this, where it's asking you to dilate by 1/2, you just take your coordinates, like x is at 0, comma 2. X prime will be at 0, comma, what's half of 2? 1. All right? It's that simple. Are there any questions I could answer about this before we get to work? All right.